In this example, we have f of x equals, in the numerator, 3x squared minus 3x minus 6, and the denominator, x squared minus x minus 6. So, let's solve for horizontal asymptote first. So if you take a look at the numerator degree, the highest exponent in the numerator is 2, and then we compare it to the denominator degree, which is the highest exponent in the denominator, which is also 2. So that means that for our horizontal asymptote, since they both equal, it's going to be y equals the leading coefficient of the numerator, in this case the 3, so 3 at the very top, over the leading coefficient in the denominator, which is 1. So my horizontal asymptote is going to be y equals 3 over 1 is 3. And then let me box that up. Now next, unlike the process in the last example, I'm going to look for the Y-intercept. So I'm going to plug in 0 into all the x's of the original problem. Now, here's a shortcut. Once you understand the concept of 0, anything that multiplies with 0 will become 0. So here, even though you do PEMDAS, 0 squared is 0 times 3 will be 0. Over here, negative 3 times 0 will be 0. And then minus 6, because there's nothing you can do over here. Now, same thing in the denominator. 0 squared, 0. Then minus 0, and then minus 6. So when you simplify this, 0 minus 6 will be negative 6 over 0 minus 6 is going to be also negative 6 in the denominator. When you simplify the fraction, negative 6 divided by negative 6 will be positive 1. So my y-intercept here, when we solve for y is equal to 1, the y value. So it's going to be parenthesis 0, comma 1. That's going to be our y-intercept. And then let me box that up. So as I stated before, once you understand the 0 concept, anything that you multiply will be 0. So when I plug in 0, basically I had 0, minus 0, and then minus 6. For the numerator, for the denominator, 0, minus 0, minus 6. Essentially, it's the constant number that you have at the very end. So negative 6 over negative 6, simplifying to positive 1, y equals 1. Therefore, my y-intercept is 0, comma 1. Alright, let me erase this, because now we're going to work on finding vertical asymptote and x-intercept. The reason I want to do those two together is because they both have the same first step. The first step is factor and simplify. So here, when I simplify, and again, I do recommend that you pause the video and write out all the work for factoring and see if your factors match with mine. Alright, so when we factor, the numerator, we have a GCF, a greatest common factor. I'm going to factor out to 3 first. So when I factor out to 3, I'm going to have x squared minus x minus 2 over x squared minus x minus 6. So I'm going to continue factoring the numerator. I still have the 3 on the outside. When I factor the numerator, x squared minus x minus 2, I'm going to have x minus 2 times x plus 1 over, for the denominator when I factor, x squared minus x minus 6, is going to be x minus 3 times x plus 2. So I finished factoring, and I cannot simplify this fraction because you don't have any common factors. For example, x minus 2 and x plus 2 are different factors, so I cannot simplify, meaning I cannot divide since they are not common factors. So this is what I have. Now, let's find vertical asymptote. So for vertical asymptote, we're going to focus on the denominator factors. So x minus 3 and x plus 2. We're going to set it equal to 0. So here I'm going to add 3 to both sides. X equals 2, 3. Here I'm going to subtract 2 to both sides. Here x equals to negative 2. So these are my two vertical asymptote. So VA, vertical asymptote, x equal to 3 and x equals to negative 2. Now again, these vertical asymptote are vertical lines. So that's why it's okay for us to write as x equal to 3 and x equal to negative 2. Now for the x-intercept, we're mainly going to focus on the numerator factors and set it equal to 0. So x minus 2 equal to 0 and x plus 1 equal to 0. Solve for the variable, so add 2 to both sides on the left, so x equals to 2. Here, subtract 1 on both sides, so x equals to negative 1. So therefore, my x-intercepts, so before I write that out, if x equals to 2, my coordinate point is 2, 0. If x equals to negative 1, it will be negative 1, 0. So my x-intercepts will be 2, 0 and negative 1, 0. So let me write that parenthesis, and then let me box that up. Alright, the next part is now we're going to use the horizontal asymptote, the y-intercept, the vertical asymptote, and the x-intercept. We're going to use all this information to make our graph. So here, I wrote down the horizontal asymptote, I wrote down the y-intercept, the vertical asymptote, and the x-intercept. So next, we're going to plot them, and then this is what you're going to see for your graph. So my horizontal asymptote, it says y equals to 3. So that means it's going to be a horizontal line where it's going to be at 3. So on my y-axis, 1, 2, 3, right here, 1, 2, 3, it's going to be a horizontal asymptote. And I'm going to draw it like this. Next, I'm going to draw my vertical asymptote. It's going to be a vertical line going through the x-axis. So my x equals negative 2 is going to be over here where x is negative 2. So it's going to be a vertical asymptote. And then x equals to 3, so 1, 2, 3, right here, 1, 2, 3. So this is going to be my second vertical asymptote. So since you have two vertical asymptotes, you have two vertical lines. Now for the y-intercept, 0, 1. So right here, 0, 1, this is my y-intercept. So let me mark that in black. And then my x-intercept, negative 1, 0, which is right here. And then 2, 0, which is right here. So lucky for us, we have 3 points in the middle. So as you can see here, 3 points. That means that we can make our graph. Now the one thing about our vertical asymptote is that when you make your graph, the graph cannot go through or go past the vertical asymptote. So when you're making your graph, your line cannot touch nor go through the vertical asymptote. So with these 3 points, they have to be connected. So when you make your graph, you can make it where it goes along the vertical asymptote. And as you can see, I'm going through all the points that I made and then going back down, and it's going along the vertical asymptote but does not touch nor cross. So again, I use the Y-intercept and I use the X-intercepts to make my graph. Now the other side, when we're making our other graph, again, they do not cross the vertical asymptote nor they cross the horizontal asymptote. So in the middle graph, most of the time, if your middle graph is going downward like this, then your other side will go like this. That's my left side, and then my right side of the vertical asymptote is going to go like this. It goes along the vertical asymptote, do not touch nor cross, and it goes along the horizontal asymptote. According to the end behavior, it goes along. Now let me clarify something. Now the left and the right graphs, they don't cross nor touch the vertical asymptote and the horizontal asymptote. Now for the one in the middle, the one thing that they do not ever touch is the vertical asymptote. But sometimes, and I do recommend that you make a note, sometimes the middle graph can go through the horizontal asymptote. So you're going to come across some problems where the middle graph, if you have two vertical asymptotes, the middle graph, two scenarios. It's either going in the same direction, like you have here, or sometimes it can go through the horizontal asymptote. That's for the middle graph. Only for the middle graph. It doesn't touch the vertical asymptote. Sometimes it doesn't touch the horizontal asymptote. Sometimes it can go through the horizontal asymptote. Now the outer graphs, the left graph and the right graph, they never touch the vertical and horizontal asymptote. So I repeat, they don't touch the vertical asymptote and the horizontal asymptote. They use the horizontal asymptote and the vertical asymptote to determine the end behavior. So as you can see here, the graph is going along the horizontal asymptote just like it's going along the vertical asymptote. That's for the right and left graphs. But if you do have a middle graph, it follows the vertical asymptote. Two scenarios. It doesn't touch the horizontal asymptote. That's the first scenario. The second scenario is it might go through the horizontal asymptote. But again, that's only for the middle graph. I do recommend to make note what I just covered so that you know the distinction between the middle graph. Either does not touch the horizontal asymptote or go through the horizontal asymptote. Make sure you make note of the middle graph when you have two vertical asymptotes, and then make note on how to make your left and your right graph.